Hello everybody. Today we're going to be talking about the standard normal distribution. Okay, the standard normal distribution is made up like this. You get a data set and you graph it. I've talked about this a few times. You get a distribution and this is made up of x values. It's made up of x values. So this distribution is symmetric. So what we could do is we can model it after a normal curve. And if we notice here in the middle is going to be our average. It's going to be our average. So here would be kind of like one standard deviation away, and here would be like -1 standard deviation away. So instead of dealing with the real data, we find the z-score for every data point that we have, and we model it under a normal distribution. And we call this the standard normal. The standard normal. It's made up of z-scores. Okay? And one thing that's tricky would be, what is the mean of a standard normal distribution? Well, that would be 0, because the question I'm asking is, how far away is the z-score, or what's the z-score for the mean? So for example, if I said the mean was 50 and there was an x value of 50, how many standard deviations is 50 away from 50? Well, that would be 0. And then this would come over and this would be 1, this would be 2, this would be -1 and -2. And it's important to note that when you're doing these, when you're drawing it, it's good to practice too. Make sure you practice doing these. If you're in a statistics class, practice drawing these curves, okay? Now, so the one standard deviation is always going to fall away. If you got this curve and it's curving down, it's curving down like this, and then there's going to be like this straightaway point, and then it's before it starts to curve the other way. Okay? Calculus, we call this an inflection point. Okay? Is the point when it changes from convex to concave. But here, it's going to be somewhere right about here. So that's where your one standard deviation is going to be. That's where your one standard deviation is going to be. Okay? And what's the good thing about this standard normal distribution is you could take any data set, okay, whether the data set consists of x's, whether the data set consists of x bars, whether the data set consists of p-hats, which we'll learn later, okay. So it doesn't matter what the statistic is, we could always turn these things and send these to the z distribution, okay, to the z distribution. This is a normal curve. The middle is 0. This is 1 standard deviation, 2 standard deviations, and 3 standard deviations. This is -1 away, -2, and -3. And by the empirical rule, which we learned earlier, we know that, remember, the area under this curve is going to be 1, so 68% of the data will fall from here to here. 68% will fall within. This is what within means. Within 1. Either this way or this way. Okay, and 95% will fall within 2 standard deviations from here to here. So 95% will fall within 2 standard deviations. And the last one we learned was 99.7% will fall within 3 standard deviations. Hold on here. From here all the way to 3. So 99.7%. Remember, this was the empirical rule. The empirical rule. So we're going to be doing much practice later on how to find the area under these curves. Okay, because the area under the curves represents a portion of the whole. Okay, meaning that the whole area under this z chart, the z distribution, okay, this is everybody. This is the whole. If I cut this whole and say all I want is this part, then that's part of the whole. So this is a percentage of everybody. Okay? Okay, there was one more thing I wanted to talk about before we go on, and that's the notation that you're going to be seeing. Now, a lot of times, they'll give us the distribution of the population. It's not from some sample that you've taken. So when we're talking about the population, it's very important that you understand what this is. This is called mu, I think they just describe it just like that. And the standard deviation, this is the standard deviation. And remember, this is going to be of your population. So this is everybody, not just 100 people, not 1,000 people. This is everybody. Okay, so the middle would be mu. And all these data points are just your x's, just like before. Okay, so what we want to realize that once we take this population data and we're going to send it, we're going to standardize. That's what we say. We standardize all these x's and we're going to turn them all into z's, because these are very important because it tells us how many standard deviations away we are. Okay, it tells us how many standard deviations we are away from the mean. Okay, so I'm going to turn all these x's into z's. So that'll be 1, 2. This one will always look the same. -1, -2. Okay, and when we do this, this is going to be normal, and the mean will be 0, and the standard deviation will be 1. Okay, so that's all I wanted to tell you to finish up. So I appreciate you watching. Thank you, and have a nice day.